And welcome everyone to today's Synergist webinar, Heat Stress and Vectorborne Disease, Mother Nature versus Flame-Resistant and Arc-Rated Clothing. I'm Ed Rutkowski, editor of the Synergist, the magazine of AIHA. I'd like to thank all of our attendees for joining us today, and especially Bulwark for sponsoring this webinar. I'm pleased to welcome back today's speaker, Derek Sang. Derek has been involved with the flame-resistant clothing industry in a variety of roles for over 25 years. He has worked directly with end users developing and implementing flame-resistant clothing programs specific to the customer's hazards, and he has worked closely with Fortune 1000 companies to educate them on the various fabrics, FR technologies, and the dynamics of arc flash and flash fire hazards as they look to develop FR clothing programs. Derek has developed and conducted over 250 educational and informational seminars in the U.S. and internationally. In his current position as a technical training manager, Derek has developed over 40 hours of training curriculum for Bulwark University. He is a recognized subject matter expert, qualified safety sales professional, certified environmental health and safety professional, and a certified virtual presenter. Now I'll turn the presentation over to Derek.
Ed, thank you, and thank you for saving the audience from listening to the long version of the bio. Appreciate you paring that down. Everyone, good morning, good afternoon, live or archived. I first and foremost want to sincerely thank you for taking time out of your valuable day to listen to a little bit more about heat stress and vector-borne disease. Believe it or not, as we're going into the cooler months, this is the probably the best time to gather up information, because before we know, it'll be hot again and it'll be time for those little critters to start being pesky. So we're going to talk about Mother Nature a little bit, and more importantly, when it is also a hazard, when we're also dealing with flame-resistant arc-rated clothing for additional thermal hazards. So with that, let's get all the legalese out of the way. This presentation is for informational purposes only. Customers of Bulwark Protection are solely responsible for conducting their own hazard risk assessment to identify safety hazards in their work environment. Customers of Bulwark Protection are solely responsible for selecting appropriate garments and personal protective equipment for their employees. Employers must ensure wearers use, care, and maintain their garments and personal protective equipment properly. As working conditions and other factors vary, Bulwark Protection does not make any representation that these garments and personal protective equipment will protect wearers from injury. So on to the good stuff. We receive a lot of questions in and around flame-resistant and arc-rated clothing and what to do in case of extreme conditions, and specifically the heat of summer and those inevitable accompanying insects as we go through the hotter months. In our short time here today, I want to talk about really just at a high level, what is heat stress, get a little bit more into the weeds, so to speak, when we talk about flame-resistant and arc-rated clothing and how it plays a factor into heat stress and what to take into consideration when evaluating garments when you're in a hot environment. What are some best practices? And then as we wrap up, how do we protect against disease-carrying insects when DEET's not an option? So a few quick definitions. You'll hear today and in other presentations, folks talking about fire retardant. There are no fire retardant clothing as we refer to it, or as we talk to it. The fire retardant is a chemical additive that suppresses fire by interrupting the fire flow or the fire tetrahedron. And those fire retardant chemicals are either infused or are added to fibers before they're extruded to impart flame-resistant properties. And those flame-resistant properties, all it's talking about is the ability to self-extinguish. It does not support combustion, does not melt and drip and add to the injury. Arc rating, all arc-rated garments, first and foremost, must be flame-resistant, so they must be self-extinguishing. Then we take and add additional testing so that they can show that they'll protect you in an arc flash hazard environment. We'll use the acronym FRAR. You'll see the acronym AR/FR. There is no right or wrong way to communicate that, but what we're communicating as folks in this space is that the garments are flame resistant, and the garments have also been further tested for an arc rating. I use FR, or Bulwark uses FR/AR because they're first FR, then they become AR. It also can look into the FR component when we're looking at our 2112 short duration thermal exposure to fire. That's in our oil and gas industry. They just care about the garments are FR and they are compliant to NFPA 2112, and arc rating, unless they're electrical in that environment's not going to correlate. So we use that to kind of cover both. Heat stress, that's going to be the general name for several medical conditions, and we'll talk about those as we go through this as it relates to exposure to heat. And vector-borne disease, that's the general name for insect-delivered diseases, and we'll be using those as we go through this time together. So obviously, we're talking about folks that work in already inherently hazardous environments, because if you're wearing flame-resistant arc-rated clothing, you have a short-duration thermal exposure of arc flash and flash fire primarily. And then obviously, we're adding other components that are delivered via Mother Nature, heat or the environment, and then also insects or vector-borne disease. So now we have added to those hazardous conditions. And what do we need to think about? So who's at risk of environmental stressors like heat, cold, and or insects? Well, anybody working outside. And it doesn't necessarily have to be in an FR/AR environment. We can look at sanitation workers, our landscapers, first responders, or if we're looking at additional PPE for short duration thermal exposure, our line crews, drilling crews, refinery workers, in some cases, even our tree trimmers for utilities. So what is heat stress as we're talking about today? Well, heat stress is a buildup of body heat generated either by internally by muscles or externally by the environment. And primarily in our case, when we're dealing with industrial folks, it's a combination of both. There are several heat-induced illnesses that can result, heat rash, heat cramps, and obviously you can see we're escalating here to heat exhaustion, and then obviously the worst and potentially fatal, we're talking about heat stroke. We know what the key contributors are. We know how to counter those and when we can identify them. First and foremost is hydration, and we're talking about hydration, proper hydration. Water in and of itself is good, but you also need electrolytes, and you need to have them in the right combination. You can actually exacerbate a situation by overhydrating because you end up diluting your electrolytes, which can bring on some of these other additional symptoms. So water in and of itself, it's, yes, we say poor hydration. Everybody assumes water, but remember there's more than just water when we're talking hydration. Lack of rest, pushing through, looking to get the job done, manning up, for lack of a better definition in these cases. Trying to prove that you are able to get through and get on time. We need to get rid of that in extreme conditions, and we need to realize to get rest before we need rest. Hydrate before you need to hydrate. Lack of shade. When you are resting, get out of that thermal load. That thermal load is that big orb in the sky that's going to be generating all that heat. So get into shade. Then how we come to the task ourselves, poor physical fitness. That can be also your cardiovascular system. That can be also additional changes that may come in the form of medications as you go through. Hey, a month ago, I could do this perfectly fine. Hey, I've had some changes along the way that I'm not the same as I was 60 days ago, 90 days ago, or in the next season. And we have to take all those things into consideration. As we said, there's different types. And as we talk about, as we are losing fluids, think about obviously heat rash. We're now dumping a lot of fluids onto the surface of our skin. The surface of our skin is coming in contact with clothing. Moisture tends to pool in key areas. Now you have fabric, moisture, and skin rubbing on each other. You can get skin irritations in that area. That's the first and foremost is rashing. Cramps is the easiest identifier. Everybody's had those nasty ones that happen in the arch of the foot. More importantly, when we're working outside, as we're grabbing tools and we're manipulating equipment, we start to notice that we get cramping in our fingers and our digits, and we have to stretch those out. Those are key indicators that we have the onset of a heat-related illness. Heat exhaustion, we can still, at this point, we're responding to missing the first two key indicators. Our body is now letting us know that we have had excessive loss of fluids and electrolytes. We're still sweating for the most part, and we can still control our core temperature, but it's being tasked. You'll see other indicators, profuse sweating, elevated heart rate, all those things as we start to notice that. So this comes into play when we're training our workers to evaluate our core workers. What are they noticing? So this is just your body's way of telling you you need to pause. If you don't recognize that, then your body starts shutting down. And this is where it gets really dangerous, because we can go through these steps at different rates on different days. There is no absolute to where, hey, I've got 15 more minutes, 20 more minutes. That's not how it works. You can literally go to 0 to 60 in a very, very short period of time. And then you can put yourself into where you're going to need medical intervention to get you back to normal, because now you're going into heat stroke. We can no longer control the body's temperature. That metabolic thermostat has been overridden, and it will not respond, and it will not be able to cool you down, even if you started implementing more hydration, shade, cooling, etc. Now we're going to need medical intervention in order to get that reversed. So as we look at severity, as we talk about those conditions, not only observing them in ourselves, but in our co-workers, first of all, we can intercede and we can stop the onset of heat stroke by, if you recognize it early, rest in a cool area, get shade, air conditioning if possible, cooling fans if possible, even just having airflow on a sweaty body with fabrics that have air permeability is going to give you kind of that swamp cooler effect and get you cooled down. Start hydrating. Cool beverages, ideally with electrolytes. If we are getting close and we've missed a couple of those indicators, we're calling 911. And as we are waiting for that response, we are getting those folks cooled down. If that means getting ice bags into the high areas where we have a lot of blood vessels, under the arms, in the groin, back of the neck, we can start cooling that blood down, start cooling that body temperature down, and hopefully start reversing things as we have called 911, because we have missed those indicators. So common factors, you'll notice as we go through here, we haven't even got the top 10 on here, but notice that clothing is not even identified through the first 7. Age, we sweat differently as we get older. We handle heat differently as we get older. We need to recognize that. Fitness level. The efficiency of how we sweat is affected by our fitness level. Body mass index, higher BMI insulates the core, increasing sweat production, etc. Dehydration, the big one. And we all know what the common factors are. Not consuming enough water, not consuming enough water with electrolytes, use of alcohol, caffeine, sodas, energy drinks, and then certain medications can exacerbate the dehydration that we may feel going through a day. So even though the week prior I worked same level, same stressor, same conditions perfectly well, you change a couple of these factors and your body will not perform the same. Diet. Have you had a change in diet? Have you missed a meal? Have you not eaten things? And so when we say diet, it's the bigger collective as we're looking at food intake, activity level. Did we go from a maintenance type thing to where now we're excavating, we're doing more than maintenance? We have accelerated the activity level. And the big one, and we'll talk a little bit more about this as we go on, lack of acclimation. This is giving your body time as you transfer or transform from a different environment to a new environment, new working conditions. We had a 20-degree uptake in heat over the last 2-3 days, and now this is a completely different environment. We have not acclimated to it, so the expectation is we can't go out and do an 8 to 10 hour day because we've had a 20-degree increase in heat. We've got to build up to that. It's been noted going on vacation as little as 1 to 2 weeks and coming back, going to a moderate climate, coming back to a hot climate, you need to acclimate again. So there's been a lot of work done on acclimation, and it's been shown to be very effective if we stage getting back into these extreme work environments, especially during summer temperatures. So understanding the body's cooling mechanism. Now, really, there's 4 basic ways that your body cools itself off, and it's as it tries to stay at homeostasis. And for homeostasis, I understand that, recent studies said anywhere from 97.x all the way to 99.3, whatever your norm is. The norm used to be readily accepted at 98.6. So let's just, for today's purposes, say homeostasis 98.6. That's what my body is trying to stay at. So as I elevate heat, whether that's my activity level, whether that's the environment, or combination of both, I've got 4 basic factors. As long as everything stays under 98.6 as far as the ambient air temperature, I can activate my radiation. Heat is radiated through my skin and absorbed in the surrounding cooler air because my body right now is hotter than the ambient air temperature, so I'm going to radiate outwards. Conduction, direct contact with cooler objects, picking up that ice cold bottle of water and holding it on our forehead or the back of our neck. We've all had that good feeling from a conduction standpoint. Convection, moving air breeze. That's kind of that, just get the fan going and we're sweating into our cotton shirt, and just the breeze as it passes through can have a cooling effect. And then obviously as we're sweating, sweat evaporates, which leads to the heat transfers from the liquid to the gaseous state, resulting in a cooling effect. So those are all the things that we have access to as long as the ambient air temperature is lower than our body temperature. So 85 degrees, 90 degrees. Now we start getting into the 99s, 98s, triple digits. 3 of the 4 of those goes away, and all we have left is our sweating mechanism. All we have left is the evaporative cooling system, because remember we talked about that the radiating part, I can't radiate because now the hot environment's actually radiating towards me for going from hot to low. All the other things have gone away as far as us from a natural standpoint, and we're left with one, and that's obviously fluid dependent. We look at that fluid tank. If that's full, we can work pretty well and we can continue on, including, taking into consideration of refilling the tank, hydrating, taking some rest, and getting in the shade. We can do all the things. If that tank is very, very low, we could be putting ourselves into heat stress conditions. So know the symptoms of heat stress. Monitor your physical condition and that of your coworkers. Dress properly for the heat. We're not going to wear winter boots and winter gloves and put winter hats or beanies on our head during the hot months. That's just common sense stuff. Schedule regular breaks and rest in the shade. Stay hydrated, drink cold fluids, cool fluids, no alcohol, no brainer, including make sure we have a measure of electrolytes as we continue to rehydrate. Use proper engineering controls, safe work practices, and personal protective equipment provided by the employer. So again, employers recognizing these conditions, you're recognizing these conditions, and we're not trying to push through and try to beat Mother Nature, because if you watch what's happening in the environment, Mother Nature tends to win over time. So let's not kind of bowl up against Mother Nature here. Let's use some good safe work practices as we bring them into bear. Because why? Things are getting worse. Both NASA and the American Meteorological Society predict we can expect both more intense and more frequent heat and cold events across the country in coming decades. Huge implications for indoor and outdoor workers. And I've done my best, as you'll receive these slides in PDF, to note where this information came from. And you'll see some links to websites, etc., along the way. Heat and Awareness Day. This campaign came out. Exposure to excessive heats killed over 800 U.S. workers and injured over 70,000 in a period, basically a 15-year period from 92 to 2017. And we know OSHA, NIOSH, all the top standards organizations have recognized that this is, again, it's not going away. We have to acknowledge it, and we have to prepare for it, and we have to protect our people against it. So how does what you wear can assist in cooling? Effective fabrics will and can mimic the body's cooling mechanism, typically through a combination of lightweight, less insulation allows for more heat release, open weave, more air perm allows for more air to cool and evaporate, so you've got convection, and then obviously moisture wicking. It moves more moisture to the surface of the fabric, mimicking that evaporative cooling, aka that sweating effect that you have. So it enhances and complements your system as best it can, and the technologies are only getting better. Now we have to factor in for our discussions here today, because our clothing is more than just clothing. Our clothing is more than just an employee identification program. Our clothing is more than just soil protection. Our clothing actually is our PPE. It protects us against what? Clothing ignition. It protects us from catching fire, continuing to burn, and potentially becoming a statistic, aka a fatality, from catastrophic body burn. So when your clothing is also your PPE, what are some other things you have to factor in? Wearing the right clothing from the right factors is important. Obviously, remember, for tasks that can potentially involve exposure to short duration thermal energy, such as arc flashes and flash fires, garments must first and foremost protect and insulate, then begin to factor in these comfort attributes. So if I can't protect you, if I can't do what my primary task is against that short duration thermal energy, it does not matter how lightweight, comfortable, and how much air perm and everything I have. So I have to start from a known end, which means mitigating body burn by self-extinguishing. So I have to meet that end first, and then I can start looking at other key things to do in the heat as you're evaluating your fabrics and ultimately garments. So as we look at thing one to do in the heat, we know sweat is not as free to evaporate when the skin is covered, even with breathable clothing compared to not being covered. So not being covered is not really an option. Covering also provides some secondary benefits to where I am getting that heat load off my skin. I'm protecting against sunburn, because even though I may not be evaporating as efficiently, a long sleeve shirt and long pants in hot conditions when the sun's overhead, it's a balance. So we want to keep hydrated. Better yet, show up hydrated. Schedule rest breaks. Actually put them into the system, whether that's an alarm, whether that is an employee on the ground who is working with a line crew who is getting that bucket down after X amount of time, whatever the case may be. And then we're getting shade, we're getting out of that load, and we're getting into, best case scenario, a cool area. In some areas, they have like cooling huts. They have these convex containers that have been converted into cooling huts, to where you start on one end and you zigzag through the inside of that, and they keep pushing cold air through there, and it gives you a good 30 to 60 seconds to walk through, and it's helped cool you down, and you rehydrate, get 10 minutes in the shade, and then you're back onto task at hand. Ideally, take some ownership of it, stay in shape, careful with your medications, make sure you understand how your medications interact or potentially can cause dehydration, etc. Take note of those, and then obviously your caffeine intake and your alcohol intake over your off days. one of the most noted days for heat related during the hotter months is having sporting events on a Sunday and coming in a little dehydrated Monday and then working in those hot weather conditions. So monitor those, be conscious of those, and be aware. Thing two, look for FR clothing that facilitates evaporation. Moisture wicking fibers, make sure it's not a finish. By that, I mean it's not going to wash out. We can talk a little bit more about that, but it's better to have it as part of the fiber matrix, that there is some absorbing moisture wicking fibers in there, and it's not a finish that's going to go away in 25 to 30 launderings. Open weave. This is tough to do because that closeness of that weave helps that fabric insulate and, remember, first protect you, but we do want to have some air permeability there. So if we can protect you and we can mimic moisture wicking and still protect you, now we're getting closer to ideals. We know the challenges is when ambient air temperature is above body temperature, all you have is perspiration, your evaporatory cooling system. So try to find garments that will help mimic that, meaning that they will pull moisture from your body, quickly get it to the outside so it can be evaporated and continue that. Some of the older technologies like cotton can be challenged with that. Why? They can saturate to a point and they don't exchange that moisture relatively quickly, and you can end up just being sitting in a wet garment all day, and that's not very productive either. Thing number three, be careful utilizing PPE that involves layers and or barriers. I'm going to tell you, even though it may be counterintuitive, that single layer work clothing, whether it's FR or non-FR, regardless of nominal weights from 7 ounces, 5 to 7 ounces, is irrelevant when it comes to heat stress. It is not a factor. But as I say that, it doesn't include every combination. Arc flash suits, absolutely we must monitor our time in an arc flash suit. This is a big layered protective system that's not going to allow you to stay cool. Rain gear, as silly as that sounds, during hot months, yes, we can have rainstorms and we can climb into barriers that, even though they try to have some moisture wicking capabilities, some gas exchange between the inside and the outside, they're still challenged because first and foremost, they're trying to keep you dry. So that's an additional layer that can add to it. High-vis vests, these are typically synthetic. You're putting it over arguably a third of your body, a fifth of your body, and now you're adding additional areas to where you can't have that gaseous exchange, that evaporation, and you're adding more load. Chem protection, now you're putting on an absolute barrier, and along with disposable coveralls and soil protection, etc., depending on the task, very low air permeability, very low moisture wicking capabilities, and they definitely will and can contribute to stress. So your daily wear all day, every day, flame resistant shirt, pant, and or coverall, you're fine. But when you start adding to that, be very, very conscious that you are not going to have the same amount of time and the same amount of productivity that you would have in cooler months. Thing number four, single layer flame resistant arc rated clothing is no more a contributor to heat stress than non-FR clothing. The clothing adjustment factor, when we look at the heat index through the wet bulb globe testing, it is not a non-factor. And I'll actually show you the table here shortly. Even though many folks who may be listening think that that's counterintuitive, because FR clothing is also obviously much heavier, much more uncomfortable, that is more perception than it is in practice. Lastly, factoring in your base layers. There are advantages to having a lightweight base layer and a lightweight outer layer. That base layer can do a lot of that moisture management for you. That outer layer now can be lighter. If it's lighter, it can have a more open weave. And even though those arc ratings and that FR performance can be equal to or greater than a single weight heavier layer, that is something that may be considered when you go into the hotter months. Can I build, and where would this factor in? Most of my NFPA 70E and my utility audience have stayed away from Cat 1 shirts or basically ATPVs of less than 8. Why? Because 8 point and change was the magic number, which was Cat 2, which did about 80%, picking a number, of all the energized tasks they were covered. But if you could get, say, a lightweight 6 cal shirt over top of a lightweight 5 cal shirt, and you tested that together, it's got 18 calories of protection. You're more protective than your single outerwear layer, and those two layers together may perform better in a hot environment because they're lighter, more comfortable, easier exchange of sweat, etc., to the outer layer, more air permeability in that lighter weight weave fabric. It could be a much more enjoyable experience, and you're still staying equal to or greater protection from the hazard that you are building it from. And then the biggest thing here we wrote this for is stay away from moisture management synthetic systems, aka high performance athletic gear. And we all know what the brands are. I don't need to share that with you per se, but understand that those 3.5 to 4 ounces of fully synthetic non-FR base layers will melt, will shrink, will transfer all that to your body and cause horrific injuries. Remember, all that IR, all that radiant heat, everything is still passing through that outer layer. All that outer layer is doing is when that short duration event is over, it's not on fire. That doesn't give you any correlation to what you're wearing underneath and how that performs. If it's a lightweight meltable, it's going to do exactly what you think a lightweight meltable can and will do. It will shrink to you. All that heat, all that melted plastic will now embed itself in your skin, and you will be severely injured when you didn't have to be. What can you wear underneath your flame-resistant arc-rated clothing if you're not going to wear an additional layer of FR? Natural fibers, primarily cotton in hot months, wool in cold months, and in some cases silk. Those are all natural fibers. They will not melt and drip and add to the injury. So finding that balance, look deeper than the brochure. Don't look at marketing pieces, and definitely don't make decisions about a fabric over the top of a desk. One feels lighter, one feels softer, one feels more comfortable. Comfort has very, very little to do with performance. And that may sound a little strange, but I challenge you, next time you have an employee meeting and you're in a controlled environment, aka you're inside your service building and the ambient air temperature is 78 degrees. Take a note of what everybody's wearing. If you have more than 20 people in the crowd, you'll have a variety of clothing ensembles and how they came to work that day. You'll have short sleeves, you'll have polos, you'll have t-shirts underneath long sleeves, you'll have hoodies, you'll have sweatshirts, you'll have long sleeve shirts, buttons. Go with whatever combination you like, and I trust everybody in the room dressed for comfort, because comfort is completely subjective. So when someone says this is the lightest, most comfortable garment, it's nonsense. It doesn't correlate. First and foremost, what should you care about? That the garment protects against the hazard that you have, and your people, if they're unfortunate enough to be in an arc flash or a flash fire event, are going to come out of that as best they can based on that fabric's protection. Then look at wicking, air permeability, and weight. And how do you do that? You do that through wear tests. Fabric weight in and of itself is not an indicator of comfort. There's no perfect fiber. There's no perfect fabrics. And it's all about finding the balance for you and your team in what they do. Any good quality distributor, any good quality manufacturer will finance for you true wear test. So wear test the garments in the environment they're in. Wear test your summer ensembles in the middle of summer. Don't wear to test your ensembles for summer and winter and vice versa. So that's wrapping up just FR/AR. So let's take a look at Mother Nature bringing on additional hazards. And this is our little vector-borne disease. This is our little mossy mosquito here who has gained more traction and is causing more problems. And him and his little buddy, the tick, over probably the last 15 years than any other attribute for those who have to work outside. Insects carry a variety of diseases, from Lyme disease, West Nile, malaria, Zika, dengue fever, etc. Per the CDC, and you'll see the actual maps, between Lyme disease, West Nile, and Zika, we have almost covered every single state in the contiguous U.S. As I said, it was growing. Back in 2004, the CDC noted just roughly 30,000 cases. Just 12 years, 13 years later, we're almost at 100,000. Where we are today, 5 years past that, we're well over 100,000 cases of diseases caused by mosquitoes, ticks, fleas, etc. So it is important. Why? Because in what we do, it's all our core markets. We are providing flame-resistant and arc-rated engineering to protect those that work in and around oil and gas, electric utilities, gas utilities, upstream, midstream, downstream, it doesn't matter. They're going to be outside working at some point. And the tough thing is the number one ingredient in most insect repellents that most folks are going to reach for, they can't use. It works perfectly for repelling biting diseases. It's the active ingredient in the majority of retail level products. The downside is for those who work in a hazardous environment of short duration thermal exposures, its flash point's about 300 degrees, whether it's wet or dry. So I'm literally putting an accelerant on my protective clothing. I'm going to flash all of that off, and depending on how saturated it was, depending on how much load you put on there, depending on a multitude of things, it can cause significant and serious injuries. So how can we still use this product? Well, there's a couple things you can do. First and foremost, do not put it on your outermost layer. There are wipes that contain DEET, and you can put those on exposed skin, in and around the neck, in and around the facial areas. You can put it on the t-shirt that's underneath. You can put it on, if it's a short sleeve t-shirt, you can use those same wipes and put it on your arms prior to donning your outermost layer. How many folks are going to be able to make sure that that's maintained and you're able to do that all the time? Highly unlikely, unknown. So what are some solutions? Well, one of the solutions we have is permifrin treated clothing. And really the term we should use here is permifrin infused clothing, because there is actually some limited durability to that, meaning that it can last through multiple launderings. And the ones that we have tested and the ones that we can speak to, it's up to 50 launderings. So that's almost a year of weekly laundering that this infusion can last. So it's got a little bit more body to it than treatment does. Disclaimer here, one of the things that I've learned as we have looked at this technology and we've looked at distributing it through our supply chain is check your local laws. Countries, provinces, there are specific guidance on how they can acquire and use permifrin treated clothing. So it's not as universal as you would think. And I know we have folks from all across the globe here. So make sure that you can access and utilize this technology. So how does it work? Really, it's a knockdown. It will discourage ticks and mosquitoes, first and foremost, from landing on you. If they do land on you, they will quickly drop off, fly off, and you actually create what's neat is a halo effect. As simply as wearing an infused bandana, infused socks. It doesn't have to be your complete ensemble that has this technology, because there is a little bit of a halo effect in the garments in and of themselves. The key thing is again, with any additive, with any finish, regardless of the infusion's durability or not, we have to make sure it will not factor into injury. We have to make sure that it will go through and perform in our primary hazards. So making sure that this technology goes through arc flash and goes through flash fire protocols is key. And then making sure that all the certifications and everything are above and beyond and after the fact with the actual infusion in there. What am I saying is you don't get a 2112 compliant coverall infuse it with insect repellency and not retest it for the hazard that it's going into. It's not as simple as going out there, adding the technology and saying it's still 2112 or saying that it still has the same arc rating. You have to actually go out and verify that. So what do we know about permethrin from a knockdown standpoint? We have shown our technology to be as much as 50 launderings. The retail version, because you can actually go and say you were heading to a high mosquito, malaria, dengue fever continent, and you were going for 30 days. You could actually, in some of these companies, you can actually send in the clothing and the gear that you're going to take with you, and they will put it through this process and they will infuse the permethrin, so it will have the durability and the length of however long that stay is. And what they will talk to on the retail is 70 laundering. So why the difference? Just so you know, first and foremost, when it's done, it has to go across all your FR fabric offerings, all the way from Nomex 3A, your FR cottons, your FR motocrylics, and whatever combinations that you've used, you have to test it on all of them. Secondly, depending on that FR engineering, there is some space for additional finishes. You may have a DWR finish on certain garments. So the bottom line is there may or may not be a lot of room for this new infusion or this new treatment or this new finish, depending on how you want to label it. So when we do that, we have to test each and every single one. So what we settled on and what we saw across the minimum one we got was 50. So that's why you'll see a little bit difference in many of the retail numbers versus the FR numbers, because retail fabrics tend to have a lot more space for that finish to hold on to. Does this mean the garments they drop off a cliff? No. What happens is you'll see a gentle decline in the efficacy as far as how much knockdown effect it has. You may experience a mosquito bite here or there as you get close to the wear end of those 50 cycles. So just be cautious of that. It's not an absolute drop off, but you're going to want to rotate your inventory at some point to maintain that, if that is part of what you're protecting against. So advantage of garments that are infused with permethrin versus you having to spray a permethrin product on, or some other kind of finish that's going to have some kind of knockdown capabilities, whether that's a natural, however, there's lots of products on the marketplace. Well, first and foremost, don't spray permethrin on you ever. You want to put your gear on the tool room floor or the garage floor or the back of the truck, and you want to spray it and let it dry. Flip it over, spray it, and let it dry before you put it on you. Do not be standing in the middle of the field and having your buddy spray permethrin on you. You don't want that in your eyes, you don't want it in your nose, and you don't want it in your mouth. So by having it already infused in the fabric, you don't have any fear for harming the eyes, no chance of it being inhaled or swallowed, no potential for overuse, and repellency doesn't get near the skin because that infusion, once it's in there, is not transferring to you. Longer lasting, no reapplication is needed, no treatment transfers to car seats, furniture, etc. Once the infusion is on, the fact that it's not carrying over as opposed to what a topical spray would. It's odorless, and there's no additional laundry requirements to protect the FR properties and protect the efficacy of the insect repellency. Doesn't affect the FR properties. It does not affect the physical properties, aka change of color, and you're going to have an effective repellency against a variety of insects, as you saw earlier on. Why permethrin? It does not affect flame resistancy. It's proven. It's actually has an EPA registration number. It's long-lasting, effective, and convenient insect protection. Our militaries have been using them for well over 2 decades now. And the insect repellent on this particular brand has been highly effective on FR clothing for close to 25 years. When we looked at this brand on our clothing, we've actually had it recertified and retested to make sure that the FR properties and the ARC ratings have not changed. So bottom line, as we're getting to wrap up here, and we'll go into some of our resources here shortly, hydration, rest breaks, shade, cover are the most effective control methods with the right hydration, and hydration being the far most important. Acclimation of work programs, exposure limits with rest and work cycles, and there's some great resources out there if you Google that on working through acclimation programs, and it's been proven to be a highly effective reducer of heat stress illnesses and hence time off and work loss because of heat stress. Get out of the radiant load, schedule heavy work during the cooler parts of the day, have rest in cooling tents if possible, dress in layers, understanding how your layers work, cover your head, get that radiant load deflected away from your head if possible, put shading and increasing the trims on hard hats, etc. Wear trials, the most effective way to judge comfort. Remember, whatever that marketing brochure says may or may not stand up in the real world. Get it on your people's backs to evaluate it. And then understand how insect repellents work and pick the one that's best suited for your team and their environment. I'm going to clip through here resources relatively quickly. Just know that they're there, and then we can spend some time for Q&A. As we know, OSHA only offers guidelines and endorses NIOSH's criteria at this time. There are no regulations per se, even though we're pushing for them. There is tons of acknowledgement through OSHA. There are at the state level, they do have implemented their own standards for protecting. I believe at the time I wrote this, California, Washington, and Minnesota, and I think Oregon just recently adopted in their states language for heat stress. In fact, in guidance for heat stress came out just early part of September, discussing with the OSHA area offices so they can become more familiar with the warnings and alerts and advisories. There's website information to go to, and there'll also be some hopefully easier to implement resources as we go through these. So we saw the guidance and the heat-related hazard announcement come out. Bottom line, the memorandum basically established an enforcement initiative to prevent and protect employees from serious heat-related illnesses and deaths while working in hazardous, hot, indoor or outdoor environments. It expands on the agency's ongoing heat-related illness prevention campaign by setting forth the enforcement component and reiterating its compliance assistance and outreach efforts. The initiative prioritizes heat-related interventions and inspections of work activities on days when the heat index exceeds 80 degrees Fahrenheit. Employers will be encouraged to implement proactive interventions such as water, rest and shade, and other important prevention measures such as acclimation of new and returning workers. So echoing everything that we just went through in the last 45 minutes. Here we have Oregon stepping up and talking about their emergency rules. Ensure effective communication between employees and supervisors so concerns can be reported. Provide workers with a 10-minute rest period in the shade for every 2 hours of work. Develop and implement an emergency medical plan and practice to help workers acclimate to heat. Make sure all employees are observed for alertness along with signs and symptoms of heat illness and monitor to determine whether medical attention is necessary. So you're just, again, the previous 40 some odd slides are being echoed through all these resources. OSHA has these quick cards that you can access and utilize for meetings and safety talks. Here we have the heat index, quick guide here for water, rest, and shade, and it takes you through low, moderate, and high and what that means. So how do you get there? They have a really, really cool app. Downloaded it this last summer. Every time I went out, I'd periodically hit it and see what it was telling me. And sure enough, it was taking that previous slide and all that complicated numbers and things and simplified it for you. Boom, here's your heat index. Here's your hourly heat index as it moves through the workday. And then if you need to understand what the first aid is for, it's right there. All easily accessible. It was really cool and really easy to use. Bottom line, when in doubt, 911. Why? Heat exhaustion can go to heat stroke relatively quickly. Heat exhaustion, you are still technically able to reverse that if you implement the things that we've been talking about throughout the webinar. Heat stroke, you cannot reverse in and out self in the field. That is going to take medical intervention. There's some things you can do to help while the responders are on the way, get them cooled down, get them out of the load, get ice packs into those high concentrated blood vessel areas under the arms, back of the neck, groin, etc. But you are in 911. Here's the table I was telling you all about as far as the clothing adjustment factors. Again, even though you may think it's counterintuitive, level D work clothing, woven materials and coveralls, your adjustment factor for single layer work clothing, regardless of flame resistant or not, is 0. So again, may go against what your perception is. Understanding that perception is technically reality, but we are so removed now from the technologies of the 1990s that the sophisticated fabrics today that you see in the FR world, much better and much more adaptive to heat. These maps really quick, you'll see here we have Lyme disease primarily in the Northeast, as you would think. Then we look at our Zika. You can see the high and the low states, and then we factor in West Nile. You can see how vector-borne disease is going to affect folks in one way, shape, or another, pretty much across all of the U.S. today. And if it's not there in your state today, it's only really a matter of time, is what folks are telling us. Prevention, pretty much wear long sleeve shirts, long pants, treat clothing and gear. Again, we're reinforcing the permifrin infused garments to help knock down those diseases. So with that, thank you again for your time. I'm going to turn it over to Ed, but before I do, if we don't get to your question today, good folks here at AIHA always send me all the questions asked. We will do the best to get you the answers that you're seeking. If I can't answer your question today, I will take that question back. I will touch in with my team and find you the resources to where you can get the answers that you need. So with that, back to you, Ed, for Q&A.
Okay, thanks, Derek. Looks like we have about 7 minutes for questions. We'll get to as many as we can. Just a reminder, if you'd like to ask a question, you can do so in the chat module in the lower right-hand corner of your screen. So, Derek, the first question from Sean came in early in the presentation. You had a slide up about what to do if a worker is showing the effects of heat, and Sean asked, does the cold bath risk the patient developing hypothermia?
Great question. I mean, obviously I'm not a doctor. We want to take everything in moderation. Yes, going from extremely hot to an ice bath could shock the system. There's got to be some cautions there. But getting them in a cooling environment, in a cool tub, even just room temperature water, some submersion, utilizing ice in those high blood vessel areas that we talked about, getting that blood cooled down as it pumps through, it is effective. So again, good question. We want to be cautionary going from one extreme to the other. We definitely don't want to induce cardiac conditions by shocking the system like that. So I would not put anybody into a ice bath submersion. I would definitely get them into cool water though. But yeah, good point on the ice bath.
Okay, thanks, Derek. Next question from Mitch came in when you were talking about base layers, and he asked, is dry fit good for a base layer?
Dry fit, if it's non-FR and it's synthetic, the answer is no. If it auto-corrected from dry fit from dry fire is a brand of FR base layers, which would be perfectly acceptable. In fact, dry fire they made their name on the military side and the law enforcement side, and their base layers do an excellent job of moisture management, etc. But if dry fit is similar to other well-known performance brands and there's no FR properties and it's synthetic, absolutely not.
Okay. Michelle has a question that came in when you were going over your resources at the end of your presentation, and she asked, does this guidance apply only to construction workers, or does it apply to nurses working in outdoor COVID testing sites?
Wow, that's a very interesting question, because obviously, as we focus, we're looking at our industrial athletes. We're looking at our folks in our core markets. But I'm going to generalize here, and I'm going to say if I put on my OSHA compliance officer hat, and you've got shade tents, and you're out in a blacktop parking lot at a local sports facility, and you're using that blacktop parking lot as where you're going to be doing all this, and you've got the heat coming off of the blacktop, you've got the radiant load, even though you've got some shade, and that ambient air temperature is X, and you do your heat index and your Y, all those are going to imply you're now an outside worker. So I would say with a relative 70% confidence rate, even though it's kind of outside my area of expertise, I don't see why that would be any different than a landscaper, than anybody else who's working in those conditions. And I would say that everything that we've said applies. 10-minute breaks after 2 hours out in that heat. Make sure you're hydrated, make sure you're getting rest, make sure you're resting in shade. Even though you could argue that you're in those tents and you don't have direct load, you've got all that radiant heat off the blacktop, and your heat index could be well over 100 degrees. I would say everything that we just talked about would apply.
Okay, thanks, Derek. Another question, Gopal asks, is water-based permethrin insect repellent usage okay on FR clothing? The
answer would be yes. Permifrin in infusion, permifrin as a treatment, permifrin as a additive coming from spray has been safe for FR for close to 25 years now. The only concern is on, like I said, on that one slide, you're doing it on clothing only, not while you're wearing it. You can have the potential to overuse. You can have the potential to do those things, but the biggest fear you would have is spraying that on while you're wearing the clothing. If you're not doing that, then it's going to work. It's going to be safe for the FR. Even if you were to accidentally overuse it or spill it on a spot, you're not going to impart or do anything to the FR properties. The biggest caution and the biggest reason we stay away from promoting something that at this time is the fear of spraying in, especially airwaves, eyes, ears, skin, etc. Then the last thing is you've got to be cautious of, that is not a infused bond. So when you get in and out of your personal vehicle, you are applying permethrin to those car seats. When you're getting in and out, when you're walking around your house and you're sitting on your clothing, when you're picking up your kids, however you may do it, that is not a very, very strong bond with that spray on, and you could have some transfer. So again, be cautious of it. Probably a few training points you need to go over every season with your team, but there's no reason that you can't utilize a water-based permethrin spray.
Okay, thanks, Derek. Unfortunately, that's all the time we have for today. If we didn't get to your question, we'll be sure to pass it on to Derek, and he will reach back out to you. My thanks to Derek Sang for his presentation, to Bulwark for sponsoring today's webinar, and to all of our participants. Please join us on Wednesday, December 8th, when Derek returns to deliver the last Synergist webinar of the year, FR/AR Myths and Misconceptions. Thank you again, and have a great day.
All right, this was great. This concludes today's webcast. Thank you all for attending. The recording will be available at aiha.webment.tv. We will send all registrants an email tomorrow with this link. And please visit our event calendar to sign up for future webcasts.